All right, we're back at it. John and Josh here, Josh and John, whichever one we are. So we're doing the fan reverse kit. It's about $40, $30 for a fan reverse relay. So pretty heavy duty, can handle 80 amps. We also have our switch. That's the momentary. So point that out a little bit later. So hopefully this is gonna work. I think it is, but it should be pretty easy going. Just a little bit extra wire. Also, we got 50 feet of 12 gauge wire. So that should be more than enough. So let's get at it.
Let's do it.
So these are the same switches that I had. This is the one I modified. They're both 4 pins. I'm gonna try to make the 4 pins work with my reverse relay switch, $30 on Amazon. But basically, normally it works like this. It has just a momentary up, momentary down, or momentary in and out, momentary reverse, momentary normal, whatever we want to call it. This one I modified so that it's permanent in each position. I just took an on-off on switch, tore the guts out of it the same way, and then I used those same little metal rockers that were on the other one. I used those metal rockers that are inside. You'll see this one started failing on me, so it's probably going to be a little dirty in there, same way the other switch was. So you can see there, one of the little rollers is fine. This one started to fail. So I just got a little too hot because it can't handle that kind of current. And then if you look here, you can see how dirty those tabs are. They're just not quite the way they should be. Especially that one there. That one's pretty dirty. And then if you look in here, you probably see some melted sections. So, because these aren't made for that kind of current. But basically all it does is you have your power in, you have your positive or negative either way. And then when you have it going through these switches, it'll basically let them go normal, or when you connect the other side, it flops it over. So this is basically like, this is like the output normally in between. So it'll be touching the bottom 4, or then when you rock it up, it'll be touching the top 4, and then it'll just reverse the polarity when you do that. And then in the middle, it's not touching anything. It's basically these things are floating above the contacts. So when you go one way, it connects the bottom 2. When you go the other way, it connects the top 2, and it just, you see right there, just flips them. That's all it is. Pretty simple. So, which is the same thing that this switch is going to be doing. So this is the reverse relay that I bought. That one's trash. So the way this one works, you have 2 lower amperage connections. So those are what these are going to be coming in with. And this one does the same thing, but it's going to be a momentary. You have the 2 lower power ones. You have your main power from your battery, your negative and your positive in the middle. And then your output is going to be reversed. These are the heavier gauge, stronger ones. So these ones, these have constant power. This is switched. This switch will have constant power. And then if this gets positive and negative, it'll have the output on these go one way. If these become negative and positive, it switches the output on these. Now, if you really wanted to be thorough, you could do 2 of these. That'd probably be the better way. This can handle like 80 amps or something like that. 80 amps. So this can handle way more. I think it's like 20 amps for the fans. So this is going to be able to handle both fans fine. I'm going to be connecting both fan wires. So it's going to be 2 positives and 2 negatives to each of these terminals. So both of these fans are going to be running off this one unit, but it'll be plenty to handle it. But what's going to happen is if one of my fan relays, those redundant fan relays that are stock, one of those fails, it's going to put all the load on the other relay. And then I'm probably going to have both of them fail pretty quickly. So because all the wiring is going to be going together after those relays, and the fans are both fans are going to be trying to take power from either both at the same time, or if one fails, it's going to be taking it from one at the same time. So that's the risk that you run. The reason I'm not too worried about it is because the stock computer and the temperature gauge, if you get above 250 degrees, it starts beeping at you. So that's a little, and I'm always looking at my temperatures anyways. So if something is going wrong, or if this thing fails, or if one of the relays fail, then I'll keep an eye on it. But if you really don't want to be safe, you can buy 2 of these. So instead of it being like 40 bucks to make this kit, it'll be like 60. So still worth it. All right, so this is the main wiring harness that is all tucked in underneath here. These are the wires that you can avoid cutting. If you don't want to cut into your stock harness, you can buy a Hess. I think it's Hess that sells a wiring harness reverse kit. You could just use those. That way, if you do want to put it back to stock, or if you sell the machine, you don't want to have cut wires, that'll work fine. But basically what I did is, you got the blue and the black. Blue is positive, black is negative. I just connected the 2 blacks and the 2 blues in here. So I have all the fans are running off of 2 wires. So you can see here, the 2 fans are 2 wire each. So this is the other side of the switch that I had. The 2 wires going into that switch. So really not impressive, but pretty easy to do. So all of these wires were just going right up into the back of, right above my radiator vent, right through this hole. That's what we're gonna improve. So first thing we gotta do is figure out where to put this relay. So we're thinking that's gonna be the best spot behind the passenger seat. Alright, so first hole's drilled. Looks like it's going to be right behind our emissions nonsense there, so that should be fine. Alright, so we found the location for the relay. Should work down there. There's plenty of clearance with the seat, so just drilling it out. Alright, so that should pull through now. Just tuck it along the same wiring harness that's already there. That's coming out normal when we test it. So I just ran it through the hole here. It's coming up back to where the switches were. I think we're gonna have a little bit extra, so I might need to trim some of it, but that's fine. From the other side, go along the same route, since the fans are already running that way. And then these guys were here. So that's where we're trying to get. So I think I go through here. here or here. All right, so now we just got to connect these guys. All right, so I think this one's ready to go into place. This one I can put into its place. Just getting all the wires all kind of neat. All right, so that's all good. Okay, so the ones we just did were to this, and then these two were to these two. So let's just do these two the way I think they go. These are going to the fans.
Damn.
Where are those ones going to?
They're coming from the switch, the reverse polarity switch, into the unit. So that's what reverses the outputs. These are the main fan power, the normal fan power, and then the output for the fan power. This is what's reversing to. Okay, so now
Damn.
we just need to test this thing out. So this will work. I just have to do the permanent on-off thing.
What's that? What are you doing?
What am I doing? These are the old parts that make it momentary. So just the shape of those make them momentary. The shape of these makes it permanent on, off, on. So that's the only difference between those switches. So turns out the one that we just made is not working with the momentary. It's only on when we're holding the button down. So we're gonna modify our new switch with the old parts I just cleaned off. So the little tabs are dirty on these two. Still a little dirty. Good enough. Good enough. And then those little rollers on the other one, those got burned out because those are taking a lot of heat through the little switches when it's running too much current. So we won't have that issue now because this thing's not running nearly as much current. So should be good to go here. Make sure that those line up. Or don't. So now we just converted that to permanent on, off, on instead of a momentary. So I think we're in business. So the fans are blowing the opposite way I wanted. So we kind of guessed which one was which. So now what I'm going to do is just make one reversed. Okay, so I've got the two ones going in are opposite now, and then the ones going out. So we got red and black, and on out we've got black and red going out. So that way that should make my switch work the way that I wanted it to. So now, key it on. No, we didn't connect the power yet. Should probably do that. It's working.
Cool.
So when it's in the middle, the only thing about this switch is when it's in the middle, it will override everything, so it won't turn on even with the fan override. So you gotta make sure you always have it either off or on. But turn it off that way. All right, it works.
Perfect.
So now that fan override's on, now if I push it this way, it's blowing in the cabin. And then if I put it that way, or the opposite way, it's sucking the air out. So now the other question is, let's let it. I don't know what that noise is. Huh.
Relay was on. Uh-oh.
It has direct power. We just wired it directly to the battery, the switch, and it's doing something with the relays when it's off. So we're gonna fix that. Easy fix. So we already have power that's key on anyways for all of our other stuff. We'll just put it to power. We'll give it power from that line, which I don't need to put that in video, it's obvious. So otherwise, that's the only thing that we kind of overlooked because this was a quick little thing, but let me get this thing up to temp and see what it does. Show you that it will automatically, when it gets up to about 210 degrees, it will automatically kick on the fans without the fan override on. Fans just kicked on. You can hear them. Fans just kicked on without us touching anything. So it's showing 207. Now it's blowing really warm in here. It's up from 207 down to 195, 194. Now that was 5-6 seconds. So if I turn the fan override on, watch what it does. When I hit the fan override, just make it blow in here manually. Look at the temperature just idling. So I just turned it on 5 seconds ago. There's probably a 3 or 4 second delay on the actual temperature gauge, but and I have hot air. You can feel hot air all the way up in the windshield here. The hot air coming in. Yep. 168. 164. That's the fan override. That's as cool as I want it to get right now. So I'll just let it go back. So when the fan override is off, it just works like normal. If you're driving it really hard and you're in the cold, that's when you really get a really good benefit, because you can be driving it at like almost full red line and you have the automatic fans on without the override, and you're still going to be getting really hot air in the middle of winter, and you're going to be comfortable. So this thing, especially with the windshield, it's amazing how, like, I'll be driving literally in shorts and sandals with this thing going, and it works absolutely perfect. So still a couple little things you got to do. You got to do that reverse polarity. It has to be constant, not a momentary switch. But this is way overkill for both. If you want to really have the redundancy, you can do 2 of those $30 pieces, make it work that way. But I think piping both of those both of those fans into that one relay system is totally fine. And this little reverse switch now is taking no amperages at all. It's just basically sending signal for it to work the relays. So I think so far that's a success. We'll see if it fails when we're actually driving it, but I don't think it will.
Well,
all right, say bye, Selena.